Today is basically a review day on solving, and then what was the one we just learned yesterday? A U substitution. All right, that'll come in at the end. We aren't going to do any of those till near the end. So this first one, it's just, can you remember how to solve when you want to make the bases the same? Hint, I wouldn't try to use a log here because it'd be a lot easier to just make the bases the same. All right, I'll give you a moment to see if you can solve that one. Okay, let's see if you did it the same way I did it. This is a unit that's famous for many different ways to solve equations. So I personally want to make these both have a base of 4. Could you have had a base of 2? Sure. But I personally am using a base of 4. Could you have used a base of 1/4? Yes. But I think it's easy to change 1/4 into 4 to the negative 1. And then I think it's easy to change 16 into 4 squared. And then you might have done it in a different way and gotten the right answer, but here's what you do next. If you make the bases the same, then the exponents are equal. Negative 2x is equal to 2x plus 2. I'm going to subtract 2x from both sides. And that makes it negative 4x equals 2. Divide both sides by negative 4, and x equals negative 1/2. Now, if I was questioning myself saying, dang, I wonder if I did that right, I would go back up and put it in here. And I'm challenging you right now, everybody, put in 1/2 and see, sorry, wait, it's negative 1/2. Put in negative 1/2 and see if this thing actually works. That makes negative 1. And what's 1/4 to the negative 1 power? 4. So 4 equals, and then this one makes positive 1/2. 16 to the 1/2 power is the square root of 16, which is 4. I know I'm right. So I'm warning you, on today's lesson, there are multiple times where you get an answer, and then it turns out it doesn't work. So if I were you, I would check my answers. Not saying that you did it wrong. You could have done all the steps right and get 2 answers, and then one of them doesn't work. So you've got to check for that. Right. If the bases are the same, it's super simple. Good things happen when bases are the same. Well, if the bases are the same, I've always said the answers are already there. In this case, you just go, okay, well then, that gets to disappear. And that gets to disappear, and then 2x minus 1 is equal to 11. That's all there is to it. So would you please solve that and make sure that the answer actually works? I'll pause for a second while you try that one. All right. Should have said that x was equal to 6, and then should have said that it actually worked. Did you get the same thing? Okay. So let's move on. This one, you got logs on both sides. Boom, they're gone right away. That's all you got to do. What if there'd been like another log here? Can you do it then? No, you cannot. You have to have it down to 1 log on each side. That's why I always say, if you've got 2 logs, you need to condense them. Right, well, this is 1 log on each side. They're just gone. X squared equals x, and that's all fine if you know how to solve quadratics. Do you know that the first thing you got to do is set it equal to 0? And then do you know that you're always supposed to look, if you can factor it, you should? Would you please finish this one? How many of you are already done and have checked it? 2 people. All right, be patient then. So you get 0, and you get 1, and you forget Mr. Server's advice. What happens?
You get the question wrong.
Why you get the question wrong? 0 and 1 are the right answers. Where are they? Did you check it? Did you actually put a 0 in here and realize that, oh crap, I'm doing log of 0. That doesn't exist. Cross it off. Extraneous. That's why I gave you time to try to find that. All right. So, actually put in 1. That works though. How many of you caught that? Only 2 people. Do you see why I'm afraid on the final a lot of people aren't going to check their answer? Because you didn't. You know, and if you check it, it's not that hard. So take your time, check your answers, make sure they work. It's not really that hard. You just stick them back in. All right. What if the argument has the variable in it. Well, this isn't like, oh my gosh, now it's really hard. It's just different. So rewrite 2 to the, say it, 9th equals x plus 5. That's all there is to it. And then you subtract 5 and you're done. These are actually some of the easier ones. But what if the log isn't alone yet? Then the first thing you do here is add 5. Would everybody please solve this one? And I'm afraid for a couple reasons. I'm afraid some people won't get rid of the 5 and the 3 first. They would have tried to rewrite. I'm afraid that some people won't know what to do because there's no base, but there actually is a base. I'm also afraid that some kids are going to see the negative in there and go, oh, the whole thing's no solution. You can't have a negative x. No, that's not right. You just have to use negative values for x. That way you'll have a negative of a negative and it'll be fine. But if you got an answer that was like x equals 6, you can clearly tell it wouldn't work. All right, so a lot of things said there, just to kind of remind you, traps. But start with adding 5 to both sides. I'll give you a sec.
Negative x equals 5.
All right, so I'm going to use log base e because I like to write out the base. Second technical issues here. Log base e of negative x is equal to, and after you added 5 to this and it became 15, and then you divided by 3 and it became 5, you're down to this. Now what?
Now I rewrote it as log e of, or not, e to the 5th power equals negative x.
Nice. And now why can't you just stop right there? It's really close.
Then you should solve for,
Just x. So what's the final answer?
isn't it just e to the 5, or e to the power 5?
So I should just ignore this negative right here? No. So you multiply both sides by negative 1.
Oh, okay.
Final answer?
Negative e to the 5th.
That's it. And I even checked it and made sure it worked. Did you check it to make sure it worked? Have I not pounded that hard enough yet? So how do you check to see if it works? You stick negative e in there. And you might think that's going to be super hard, but it's not. Whole point is it works, usually. So if I have a negative e to the 5th, then the negatives cancel. And then ln means log base e, and all of a sudden that's just 5. 3 times 5 minus 5 is 10. Cool, I know it works. You can walk out of a problem much more confident then. I know that worked. Okay, how many of you got negative e to the 5th? All right, sweet. Well, then move on. I have said if you can factor it, you should, because I can't think of a time when it messes things up. It almost always makes it better. So I'm going to say this. If you have 2 logs, you should condense them. Now, could there be a rare case where that's not a good idea? Extremely rare. If you have 2 logs, condense them. So go ahead and condense that down. Why? Because then you can rewrite it. You've got so many more options then. So make it into 1 log. I'll pause for a second. Let me try that one. Anyway, all right. I'm ready to move on. Log base 3 of x times x minus 5 equals 1. 3 to the 1 equals x squared minus 5x. Did I go too fast there? I went that to the that equals that. Okay, now I'm going to subtract 3 from both sides. I got 0 equals x squared minus 5x minus 3. And then I bet it factors. I mean, they almost always factor. All right. So where did I make a mistake?
It's incorrect. So divide.
Oh, it's a divide. Okay, thank you. Okay. I wish somebody would have said that earlier. Appreciate you letting me know, though. All right, so now I have to go back in here. And I've done that more than once. That means to me that you guys might do it too. If there's a minus here, it's totally different than if there's a plus there. All right, so add x minus 5 this way equals 1. Then it's a rewrite. 3 to the 1 equals x over x minus 5. And then the rules kick in. If you can factor it, you should. Can't factor it. What's the next rule?
Do the fraction.
Clear the fractions. So I'm multiplying by x minus 5 on both sides. And that cancels. And now I've got 3x minus 15 is equal to x. So we're going to subtract x from both sides. 2x minus 15 equals 0. 2x equals 15. X equals 15 halves. Now, if I wanted to be sure I was right, I'd go back in and put that in the equation. And frankly, I don't want it because it's going to not be very nice. But how about this? How many of you got 7.5 for your answer? Okay, good. Now, if there was no calculator, this would not be fun to try to check. But if I was really confident that I'd done it right up to this point, then maybe right there I could try putting in 7.5 and 7.5 and see if that one simplifies down to 3. See what I'm saying? Safer to put in the original, but all right. So I'd have, well, I could say it's 15 halves. That's the same as 7.5 over 2.5, which is the same. 2.5 is 5 over 2. And then I'm going to flip and multiply. And does that really equal 3 times by 2/5? Look at that. It equals 3. 15 divided by 3 is 3. Or sorry, 15 divided by 5 is 3. So now I know I'm right. Sweet. Okay. And this one. I hope I gave you enough time there to condense this one and get this one done if you haven't already. This one would be a log of 5x. And then this one's the one where it goes like this. Equals 2. And then there's no base. So I put in a base 10. And then it'll be 10 to the second, which is 100, is equal to 5x squared minus 5x. That's me multiplying this out. Kind of skipped a step there. That's dangerous. Then I get 0 equals 5x squared minus 5x minus 100. And what do you know? It factors. 5 factors out, x squared minus x minus 20. And then it's 5, and then x minus 5 and x plus 4. And if I'm right, it's 5 and it's negative 4. But I'm suspicious. I'm suspicious that one of these is wrong. Would you go check and see if one of those is wrong? When you put in the negative 4, right away you can tell it's wrong. You can't do log of a negative number. So that one's out. Extraneous. But what if I had somehow messed up my factoring and it wasn't really 5, it was like negative 5? Well, I can check the 5 and see if it works. So I put a 5 here, and I put a 5 here. And so it's log 25 plus log 4 is supposed to equal 2. So those are the same base, so I can combine them, right? So that's log base 10 of 25 times 4, which is 100. And that's supposed to equal 2. And oh my gosh, it does equal 2 because that's 10 squared. And so log base 10 of 10 squared is 2. Yay, it worked. Okay, so double check yourself. I'm telling you, it'll cost you if you don't. All right, these are the last 2. Would everybody please solve these fairly quickly? And check with the kid next to you and see if you did them the same as they did.
125.
Okay, so 125 to the.
1/3.
And what is that actually?
5.
All right, so 5 equals, and then all that other stuff. 3x minus 2 over 2x plus 3. What's the next step?
Through the fraction.
So multiply by?
2x plus 3.
Excellent. And this is 10x plus 15 equals, cancels, 3x minus 2. Cut to the chase. What's x equal to?
Negative 17 over 7.
And I know that's weird, but we even checked it last hour, and it works. Yay. Okay. Then, no, we didn't check that one. I could be wrong. But if I wanted to check it, I would probably put it not in the original because it's just too painful, but I'd probably put it in the rewrite right here and try to stick it in there. But let's not do that, save some time. I still have to sign all those passport thingies today, so let's rock. This one is your u substitution. Let u equal log base 2 of x. If you didn't do it that way, I'd like you to stop, back up, and do it that way. So this will become u squared plus 20 equals negative 9u. It'll be a lot easier because now it's a quadratic. I'll pause for a second and give that a try. Okay, so on this one, we're going to get u squared plus 9u, plus 20 equals 0. And then I'm thinking 5 times 4 makes 20, and that'll also make a 9. So let's go u plus 5 and u plus 4. And u equals negative 5 and u equals negative 4. And u aren't done until you replace the u with a log base 2 of x. And log base 2 of x. And you might have thought there's negatives, so it's not going to work. But actually, those are in the exponent position where you're allowed to have negatives. So, final answer here, 2 to the negative 5th is equal to x. And 2 to the negative 4th is equal to x. So those are basically just two really small numbers. All right. Now your homework is to do more solving of that type of question. They're found here. Have a wonderful break. Take care.